Hello everyone. I'm going to start the talk on Azure SpendOps, the art of effectively managing your Azure costs. So by now, most of us might have a friend or a colleague that they had some horror story with Azure where they've spun up a Cosmos database and a month later they've spent 20 grand by accident. So today's talk is going to focus on the cases where this occurs, how to manage that or even prevent it. So my name is William Liebenberg. I'm a solution architect at SSW. It means I go around the country trying to reduce the software development risks for my clients, mentor their teams, and just work on some really cool projects. You can find me on Twitter, and I've also got a blog site at Azure Gems. And today's code and the presentation, I'll put it on my GitHub. But before we get into the talk, we've got a treasure hunt happening here at NDC. So if you scan that QR code, you can get our app. And at the end of the talk, I'll show you another QR code, which will give you some cool points. And if you get enough points, you can actually go and collect a few prizes downstairs. No, upstairs. Cool. So you all got that? One more. So here we go. So the agenda is, I'm going to start with Cosmos DB, what it is, why you want to use it, and how to use it. Then we'll move on to why Cosmos DB actually loves your wallet so much, and why you need SpendOps. Then we'll turn that relationship around and see what we can do to make our wallets love Cosmos DB. So actually implementing SpendOps. And then some automation ideas, and then just the future of SpendOps. So Cosmos DB is pretty cool. It's a globally distributed database, it's fast, it's always available, and it's so flexible, I can just start writing an app and get out of the door pretty quickly. But it's not very cool because I've been burnt a few times, just accidentally spent too much money, and I don't really know why. Now, Cosmos, like I said, is a globally distributed database. Some people say planet scale database. It's horizontally scalable. It's a bit different to your normal SQL server, where you can scale out your read nodes and only have a single write node. It's a bit hard to do that. Cosmos is very easy, but you also get like multi-master writes. So your write operations are as close to your clients as possible. And that really is good for performance. The throughput is elastic, so you can easily dial it up or dial it down, depending on how much you want to spend. And Microsoft's got some really comprehensive SLAs for throughput and latency and availability. So I think it's like a sub 10 millisecond latency in Azure, and they stand by that. And one feature of Cosmos DB is multi-model. What that means is we can actually deal with different ways or different types of data in Cosmos. So the most familiar ones is the core SQL or MongoDB that uses document model. So you basically take a JSON object, slam it into Cosmos, and read it. It's easy. The other formats are Cassandra, Gremlin, and Table. So Azure Table Storage, key value. You can back that with Cosmos DB as well. You get all the benefits of the global distribution and high availability. So what does a Cosmos SQL query look like? Well, it's very similar to what a real SQL query looks like, but with a bit of a twist. So you can see that bit of JSON notation in there, where we're sort of querying the body type and the price of a vehicle. And the from and where clauses, it's very much the same as what we're used to. And the data that we get back, again, is in JSON format, so it's very easy to consume this data. So my journey with Cosmos is, usually Microsoft SQL. That's my default. That's what I use. I'm very used to it. Migrating to Cosmos was quite easy. There's some tools that you can use, like the bulk import tool. I can take an existing SQL database and just copy it to Cosmos DB. The new syntax is a bit to learn. There's a few quirks that you have to get used to. It's a bit different, but it's good. Deployment, like I mentioned earlier, is very easy. If I want to spin up another instance of my database in Germany, for instance, it's literally just a click away. But again, pricing is the one that concerns me. And I dial it up. I know it's going faster, but I don't know why I have to pay so much. And what I learned after this journey is that I don't need database administrators anymore. Cosmos is actually so easy, I can do it all myself. My app itself can actually manage its own performance. And it's always available, and Cosmos is growing in popularity. Everyone wants to use it. In fact, last year, Cosmos won the Technology of the Year award. So in the top 50 tech categories in the world, that's a big deal. There's a lot of people getting involved, using it, and liking it. So pretty cool. Now, how do we code for Cosmos DB? Well, there's the .NET SDK version 3. And compared to the previous version, it's a much simpler API and better naming. So Cosmos used to be called DocumentDB, and the version 2 SDK, everything was named DocumentDB, even though Azure already branded it as Cosmos DB. So a little bit of confusion, but now it's better. One really cool thing about the new SDK is middleware extensibility. So we're able to intercept all the requests that go out to Cosmos, and when it comes back, again, so we can do some authentication, we can scrape for sensitive data going in or out, and yeah, very useful. And it's better performant. So they've done a bit of work to reduce the overhead of making the queries and getting our data back from Cosmos. And not only for .NET, we can use Node.js, Java, Python, or even just a REST API and build literally any kind of app with Cosmos. Now, to get started with Cosmos, there's a few differences, like I said, between the transactional SQL and the Cosmos core SQL. And we just need to know there's not actually real relationships in Cosmos, only rules. And our application can enforce those rules. So to make it easy, there's a cheat sheet that Microsoft provides. It shows you all the operations and things you can do with queries and how to write them. And yeah, quite handy. This helped me a lot when I started. Right, so for those of us who love using ORM frameworks, we have options. And one of them is Cosmonaut. It's a project on GitHub, and it's a very nice ORM. It uses a very nice, fluent syntax. It's very easy to write apps against that. The other one, very popular, is EF Core. So it has a Cosmos DB provider. And if you want to know how to get started with Cosmos DB and EF Core, you can check out my friend Tiago's post. And in fact, he's also doing a talk next door, I think, about the same thing. So yeah, check it out. Pretty cool. Now, we can get some free testing with Cosmos DB. We don't actually have to spend any money because they provide us with an emulator. So we can install it locally, or we can run it as a Docker image. And it mimics a real Cosmos DB instance. And we can also use it in Azure DevOps. So you don't have to use it just locally, but we can run it into the cloud and test our code as we build it. So here's just a screen of the emulator running on my local machine. And to get it in DevOps, you just have to go to the marketplace. It's free. You install it. And it's just a task in your build tasks to run it. Excuse me. Cool. So now we know why Cosmos DB, what Cosmos DB is and why we want to use it. Now we're going to see how Cosmos actually loves our wallet. Why is it so expensive? And I found this tweet by Thomas Weiss that if you do the maths, one Cosmos DB request unit costs 0.00002, it's a few more zeros, 2 US dollars. And if you can do some more maths, that means you have to have 50 million request units to spend 1 US cent. So it sounds like a lot of operations for a very small cost. But again, it doesn't quite line up with these horror stories that we keep hearing about Cosmos. So what is a request unit? So it's a measurement of how much compute went into resolving our Cosmos query. So the queries that we write in the select statements, if we have very complicated queries, a bit of CPU power goes into the resolving that query, and then reading and writing data from a physical disk, and then communicating that over the wire. And everything that we do in Cosmos, reading, writing, updating, deleting, or stored procedures, they all consume RUs, request units. And our throughput is measured in RUs per second, so it's the amount of work that we do per second. And what do we actually pay for? So these three things is the throughput that we reserve. It's always available, whether we actually not use it or not. The amount of storage we have in our database, the size of our data, and then how much we're sending across the wire. So those are the three main things that we pay for. Now, just if we do a little bit more maths, we go and get the minimum RUs that we're allowed to provision for a container. And at current sort of storage costs and throughput costs, we're going to pay about $37 a month. And so that's 400 RUs minimum, but how much do I actually need? So there's a capacity planner website that we can use, and you can sort of tweak a few numbers there to say how much data you want to use, and sort of the number of read and write operations that we'll be doing per region. And it sort of works out. Oh, I wonder what happened here. There we go. So this works out to be the same as our manual calculation before. So about $37 a month at minimum requirements. So I'm going to start designing my little web application. I'm going to write a new blog engine. I'm a SQL guy, so I think, I need a table for authors, a table for blogs, and the posts. So if I think about the 400 RUs per container at $37 a month, I'm going to pay $37 for authors, blogs, posts, and all of a sudden, what the? This is a very expensive application. It's a very simple data model, but it is super expensive. So I'm looking at Cosmos DB and my head's spinning, and all I can see is this. It's very expensive. I should change the logo. But I can do you one better. Actually change the name as well, because it's called Cosmos to DB. I've never actually worked with something this expensive. And this is really where I want to introduce SpendOps. As a developer, the onus is on us to really understand the tech that we use and not to make mistakes, because we have a direct impact into the cost of each stage of the DevOps lifecycle. So if you have bad plans or bad designs for our applications, or even just write bad code and flaky tests, if it fails on a Wednesday and only on a Wednesday, we can never find out why. So there's a whole day of productivity wasted. That's sort of the cost that we're trying to avoid, as well as our applications not over-consuming resources. So, with SpendOps, we want to be able to monitor our spend, and also want to be able to change how much we spend. So if last month's sales were good, maybe this month we can spend a little bit more, make the app perform a bit better, or if they weren't so good, spend a bit less, but hopefully not affect the customer experience, just to recover some of those costs. But we also want to be able to sort of, if we make a code change today, we want to know how much is that going to cost me. And I want to project that forward for another month so I can actually come up with a budget, be aware of what's happening. So now what we want to do is to see what we can do by implementing SpendOps to make our wallets love Cosmos DB. And one thing that we can do, the example from before, I had 3 containers for each entity type. But what we can do is to use co-location. So those 3 entity types can all live in a single container. And what we'll have to do is just give everything the same ID and add a discriminator property. In real code, this is what it might look like. So we're using the .NET full name for that type as the item type property. And our other entities in the database inherit from this base entity. And we have to then take that into account when we write our queries. Now, because we're going to put all these entities in the same container, they're really different types of entities, and because it's a flexible schema, not no schema or NoSQL, it's a very flexible schema. So we have to take into account the entity type we want. So this is a generic method. So if I want authors, the type of T, full name, would result to authors. So then we'll filter out everything else that's not an author. So this is what it will look like once we've added a few items to our database. That, for instance, this item type is a blog, the next one is a user, and the last one is a post. So cool. So now we've reduced that cost of paying $37 3 times to only once. But since a while ago, what we can also do is to provision our throughput for the entire database, not just a single container. So that previously that wasn't possible, but now it is. Now, unfortunately, if you have an existing database, you can't go back and turn that feature on. You have to start again. So either you migrate your database over, or you just delete it and start again. It's just a checkbox though, so when you go and provision your database, make sure you tick that box. It'll save you a lot of money. So, and again, you can just tune your performance requirements there. It's very easy. Now, the other things we have to take into account for balancing our cost versus performance is looking at how we optimize our queries, writing good queries, and partition design. So I'll start with query performance and a couple of things that affect them. So, sort of fairly simple. The number of items and the size of the items that we get back from the database is going to affect the performance of our query. So if you select star from every container in the database, of course, you only need a little bit of that. You're going to waste a lot of compute, a lot of network, a lot of disk I/O. So the key is to focus down just what you need. And also not write overly complicated queries. Now, it's a very simple statement. It's not always possible, but do your best to write simple queries. They compile quicker, they'll execute quicker. And when you make a query to the database, you always get back the query metrics. And Cosmos will tell you how well that query ran against your index. So if your index utilization is 100%, great. If it's 50% or lower, you probably want to go and look at your query or the partition design, which we'll get to next. But also, if you have the right information in your application, you have the partition key and the ID, to get an item or an object from the database is super easy and it's super cheap. So it'll cost you 1 request unit for every kilobyte of data that comes back. And just as an example, it's a very easy little call to Cosmos. And here we make sure we provide a partition key and the ID. Now, just to be aware of, updates and deletes are very expensive compared to creating an item. So to update an item, there's a lot of comparisons, which fields to update, and checking. So a lot of compute that goes into it. And same with deletes. But you can actually make deletes a little bit cheaper. Can't make them for free, but you can use a feature called soft delete. So just like the discriminator property that we used earlier, we can have an isDeleted field and just mark that as true and include that in our query to filter out the things that we think are deleted. And there's another trick you can use, is that you can set a time to live property on each item in the database. So Cosmos will actually expire that data for you for free. So you can use both of these or a combination of these to sort of make deletes and updates, or actually just deletes, a bit cheaper. All right, so now we need to look at partition design. So there's 2 flavors of partitions, physical and logical. The physical partitions is really how the Cosmos engine decides the amount of power to put behind a logical partition. So that's the server, the compute power of that server, and the networking capabilities. So when we look at the structure of a Cosmos database, there's 1 or more databases in that account with 1 or more containers. And each container then can be backed by a number of physical partitions. So when we dial it up, we want more performance, we'll get more servers backing this container. And then the logical partitions. This is where the Cosmos engine decides which bits of data live on which physical partition. So they use a lot of cool internal metrics to figure this out. We don't have to do anything, apart from choosing a good partition key. And then after that, this is where our JSON documents live. All right, so as I said, 1 container, you can have multiple or many logical partitions. The logical partitions are backed by the physical ones. And this is really what enables that horizontal scalability feature. So if we need more performance, Cosmos can definitely provide that pretty easily. And a good partition key is what distributes our throughput evenly. So by looking at this example, let's say we're running a sort of car sales type website. And if we choose body type as a partition key, it might be a bad choice. Because if you look at the balance of data, there's a lot more sedans than every other body type. Now, when our app gets a bit busy, a bit of load goes onto that, this sedan partition can't be split up and be backed by more physical machines, because there's no way for the data to be split up and shared across more partitions. So we end up with a problem called hot partitioning. So eventually, the poor server that's backing this run out of puff, will have timeouts and sometimes just no response. So if we then look at a good choice or a better choice of partition key, let's say we choose brand, you can see now that we've got more partitions, the data is sort of spread out more evenly, and we'll have more performance, or just a better end user experience. So the key for choosing a good partition key is to choose something that's got high cardinality, so a wide range of values. And a good way to find this is, if you go and design your app, and you design your queries up front, you can pick one that's quite frequently filtered on. So if we're always filtering on brand, that's probably going to be a good candidate for a partition key. But sometimes it might not be enough. The same with how we're using brand before instead of body type. If there, for instance, becomes too many Volvos being sold, that partition might also suffer becoming a hot partition. So we can create synthetic partition keys, and by combining two fields together. So this will give us, again, the ability for Cosmos to split up the partitions and deliver more performance. Cool. So now what we can look at is how to automate our SpendOps. So we've worked out how Cosmos works and how to sort of make it sort of be efficient at not requiring too many resources, and for us to then have adequate performance. So by now, hopefully, we've all got some automated CI/CD pipelines, and we can take advantage of that. We're running some automated tests, and this is where we can focus a lot of our efforts. So we can instrument our tests and our pipelines to start collecting some SpendOps information, and then we can make some better decisions. So our regular tests can turn into spend tests. The only sort of challenge we have is nothing has built-in SpendOps. It's something that we have to write ourselves. And traditionally, a test is just considering as a pass or a fail and the amount of code that was covered. It doesn't take into account how expensive this code was to run in the real life. And it's also now basically, bring your own SpendOps. You have to build it all yourself. So the benefits of having all this automation is that if we collect the right information, we can project the information onto our production usage. And this will let us prepare a budget and avoid the dreaded bill shock. So if we know how much things are going to cost, we won't have any surprises. We'll make some intelligent decisions. And this will allow us, again, once we know how expensive a feature is, to not under-provision and get throttled by the hot partitioning problem, or over-provisioning. So we're just wasting money for no reason. We just dial it up, make it go faster, but we're not using all that performance. So we want to stay in the sort of Goldilocks zone. Now the solution for SpendOps is, with enough instrumentation, we can collect the right amount of data, the right types of data. We can persist it anywhere, as long as we can query it, and then feed back that information into our DevOps lifecycle. Now, Cosmos makes this very easy, or at least the Cosmos SDK makes it very easy. Each response back from Cosmos will give you back a request charge, and like I mentioned earlier, the query metrics. So we can start collecting this information and start building things into our application to tag our requests to Cosmos. So it could be very easy as just an operation ID or some sort of feature name. Or we can make use of the request handler, that middleware extensibility from the Cosmos database. So we can intercept every request. We can sort of know which collection and entity that it's dealing with, and collect the request charges from there. But my favorite is to just use the CQRS pattern and sort of aggregate all the requests for a particular command or query. Then even higher than that is just an overall feature. So multiple commands and queries that happen in that feature will aggregate together, and I know how much that feature would cost me as a whole. So you can come up with different strategies yourself, but I like to use these four. Now, just to sort of describe the whole process, we start here with Visual Studio. We write some code. We want to push our changes to Azure Mega Pull Request and start building the code. And that will start running tests. So we can use a real or emulated instance of Cosmos DB in DevOps. That'll run the requests and get back the responses and collect all the different metrics that we're after. Then we can persist that and put it back into Cosmos if you wanted to, or table storage, SQL, App Insights. Got a few choices. And then what we can do is to visualize that. It's always nice to show a dashboard showing charts of how things have been tracking, and from that we can make some cool decisions. Now when it comes to releasing our software, we can use a release gate. And because we have the build number and bits of information, we can query the consumption reports and make a decision. So the change that Liam made, did it save us some money? Cool. We can release the software, no problem. Or if another change that Jacob made, it's a bit expensive, so we don't let this go through. So if we set some sort of logic in our release gate, we don't allow cost increases more than 10%, we'll turn that into a spend bug. And what we do, we put that back into the backlog, make a plan, change the code, and the cycle continues. So that's cool. That's part of the whole sort of dev part of DevOps. Okay, leave that up for you to take a photo. All right, so now I'm going to show you a quick demo how some of that works. Let's go back here. All right, can you guys see that? All right, so what I have here is just a very simple query in just a demo app. And you can see here some raw SQL queries. And I've just got a bit of instrumentation around my Cosmos client that allows me to add a bit of extra context. So not only do I have the feature or the query name here, get all vehicles by color, but also know which query inside of this, which Cosmos query inside of this UKRS query is performing which operation. So when I run this, I'll show you what happens. So I'm just running my normal unit tests, and as they run, let's refresh that. Okay, let's do that again. Okay, so normal test runner there, all the tests I have available, they've ran, and just got to turn that on. All right, so what we see here is the outputs from my tests. I haven't shown you how I've instrumented that yet, but this is the result of each test being ran. So I've got a whole bunch of fields of information here. One of them is the charge. I know which feature of my application this test was related to. You can include other information like the latency, etc. And some information about which test this request originated from. So we can actually persist all this data, for instance, into table storage or any other sort of mechanism you want. And once we've run this and we've persisted the data, we've created a dashboard, we can end up with something like this. So we've aggregated all the charges against a feature or an operation. And as you can see, that one feature suddenly got a bit more expensive. And then someone went and fixed it, so restored the cost there. But here's another green one here that all of a sudden skyrocketed. So this should raise some alarm bells. Now, this is a very simple example, but I'm going to use Power BI to make this up from a simple data set. But for a real production application, there'll be a lot more lines, a lot more features, but it'll tell you definitely a good story. Now, for the production side of things, we've got a few ideas. We can track all our RU consumption with the same bits of code or same instrumentation for our tests, and put that into App Insights, for instance. It's got a very nice query engine, so whenever we need information, we can pull it down and just chart that and put that in Azure DevOps, for instance. So we always got a view in production what's happening. And we can go a little bit further. Once we have all this information, of how much consumption we're using and when we're using it, we can use some machine learning to maybe predict our demand of what's coming up. And then we can auto-scale our Cosmos DB instance to always stay in that Goldilocks zone of not over-provisioning or under-provisioning. So this brings me to the future of SpendOps. Soon, I think SpendOps will be built into all our dev tools, and it's super useful. And we won't have any more surprises because we're going to be directly in control of our spend. And we'll be able to spend our money far more effectively. And also, a lot more consumption-based services are coming. You can already apply this to not just Cosmos, but Azure Functions, ML.NET, a few more services, and definitely take control of how much you spend there. And also, I think spend tests will become as part of our definition of done. So we can't release any software until we've tested and figured out how much it's going to cost. And eventually, I think we'll end up with something as SpendOps as a service. We've got DevOps as a service. Why not SpendOps? Thank you very much. All right, so as promised, here's the QR code for today's talk. I should score you a few points. And while you guys take a photo of that, any questions? So in production, yes.
Okay, and did you consider just going straight to the log analytics or just have you used that as well? Same thing?
So the first version of this running in production was with App Insights. Since I haven't moved it to anything else yet, but certainly possible because you get that same query engine to pull the data back. Yeah. Yeah. And then take advantage. Yes. Yeah, so there's, yeah. Cheers. There is a little bit of a chicken and egg problem. When you build your app the first time, you don't have real production information. So there's not much to predict with. So you have to be a little bit pragmatic when you start, not try to over provision or anything. But I think with a lot of these tools, when you have them, it'll make that first part of getting your app into production a lot easier. Yeah. Steve-O.
What was the motivation for doing it? Did you have an oops?
Oh yeah, I had an oops. not only that, so a few of my friends, I think you're one of them. For instance, let's say you've got with EF Core, you've got a SQL application. It's very easy to swap over to use Cosmos. Now what happens is Cosmos will try and create a lot of containers like it would tables. Now, if you have a lot of data entities, you can create a lot of containers, and like I said earlier, $37 a month each. So if you don't realize this, very quickly, you can rack up a huge bill. And that's happened a few times. I know a few of my friends, they had that issue. And myself, I've started playing with Cosmos. My Azure credits disappear very quickly. But luckily, so far for a customer, after doing all of this, we've never had an issue. It saved my life, and it definitely keeps the clients happy. Yes, sir.
Just to be clear, like when you're running it through the pipeline, is that usually emulated Cosmos DB?
In the sort of this pipeline here, you can run either. So, like I showed earlier in the talk, you can spin up the emulator, or you even use a real one. There is a little bit of difference. Definitely the performance is different. The real one is faster, but the emulator one gives you back pretty much the same request unit charge. So the metrics is the same. It's just, it feels different. Yeah. Cool. Anyone else?
Are you going to share your pipelines and all the code?
Definitely, yes. So my blog is ready to go. Just need to make a few tweaks since the Cosmos SDK went GA. So the first version was built with the preview SDK. So just got a few minor tweaks to take care of. It is working, just got to clean it up, and I'll put it on GitHub. Thank you.